Sir, it is not audible.
Can you hear me now?
Yes.
So were you not able to listen to me from starting? Hello?
No,
Yes,
sir.
sir.
Okay. Good morning, everyone. Welcome to the course on design and analysis of algorithm. This is a foundation course on study of algorithms. As you all know, most part of the computer science is made up of algorithms. So if you consider some core courses like system software, it includes compilers and operating system. You know that these are all built using certain algorithms. If you in case consider some advanced courses like machine intelligence, pattern recognition, image processing, or computer vision and data mining, you also have to solve the problems in these areas using some of the algorithms. You have to write an algorithm, you have to do the analysis of algorithm. So looking at this, you could say most part of the computer science field is made up of algorithms, and being a computer science engineer, it's very important for you to learn how to develop an algorithms for a given problem. Once you develop an algorithm, you need to check for the correctness of that algorithm, and also you need to find the performance of this algorithm as well. So these are all the things which we are going to discuss in the course design and analysis of algorithm. The prerequisite for this course is that you should know some programming and you should know data structures. Let us talk about the objectives, the course objectives. The objective of this course is to learn to design and analyze the algorithms. When you are analyzing the algorithms, the emphasis is given on the resource utilization in terms of time and space. As you know, when you convert this algorithm into a set of instruction and your computer takes this instruction and execute the program on the computer, then it requires memory. It requires a main memory and auxiliary memory to store the program and data, required data. And also when you run this program, it should complete at some time. So you are going to develop an algorithm, then you are going to analyze these algorithms with respect to time and space. How efficient is your algorithm depends on the time, and how much space it's going to take is the other component to it. So the first course objective, the main course objective is to learn to design and analyze algorithms with an emphasis on the resource utilization in terms of time and space. So you learn, in this course you learn various techniques to solve the problem, or in developing the algorithms to solve the problem. So you'll understand how does it impact? How does the efficiency impacts depending upon the problem size and architectural design? The third course objective is learn to apply appropriate algorithmic design techniques for specific problems. So if problem is given to you, after you complete the course, you will understand or learn how to apply the appropriate algorithm design technique to solve a particular problem. You will also learn how to trade space for the time. That means to say, if you wanted to increase the efficiency of your algorithm, you may require some extra space. To improve the efficiency of an algorithm, you may use some extra space in a memory. So you will learn to trade space for the time in the algorithmic design. Like you will enhance the input, or you will structure the input. Pre-structuring is done before you execute the algorithm. So you'll learn to trade space for time in algorithmic design. Then finally, you will learn to improve the limitation of algorithmic power. These are all the certain course objectives. The outcome of the course, that is at the end of this course, you all will be able to, given an algorithm, you will be able to identify what kind of design technique is used in developing this algorithm. You will be able to analyze the algorithm using quantitative evaluation. The quantitative evaluation is a output oriented, wherein you will need to have predefined outcomes for the algorithm to solve the particular problem. Then you will test the algorithm to see how your algorithm performs with respect to these outcomes, whether you have got that outcomes or not, using a numerical data. So while analyzing the algorithm, you will do the quantitative evaluation. You will be able to do the quantitative evaluation of algorithms. So if problem is given to you, some practical problem tomorrow is given to you, which you have not seen, you will be able to design and implement an efficient algorithms. You will not only able to design an algorithm, you will also be able to design an efficient one. You will also be able to analyze the time efficiency over trading space. They will contribute an extra space to improve the efficiency, or you may take some extra space wherein the time efficiency could be, decreased, right? You may reduce the space required, wherein time efficiency may increase. You may use extra space, right, to improve the efficiency. So you will be able to do these analyses in terms of space and time. Finally, you will be able to understand the limits of algorithm and the ways to cope with these limitations. The textbook which is used for this course is Introduction to Design and Analysis of Algorithms by Annie Levitin, which is from Pearson edition, Education. Then you will use 3 reference books: Introduction to Algorithm by Corman, Fundamentals of Computer Algorithm by Howard Sahani, Algorithm Design by John Kleinberg. So let me give you introduction to design and analysis of algorithms. Let us assume that you have developed an algorithm to solve certain problem. That means to say you have designed an algorithm. That means to say you know the system. You know what inputs should be given. Pardon?
Your PPT is frozen.
Okay. Now it's visible.
No, sir.
Now can you able to see? Are you able to see this? Let me know once you were able to see the next slide.
Sir, we can see only front page.
Pardon, I'm not able to hear you.
You can only see the first slide of the PPT.
Oh, is it?
Yes, sir. Now it's working.
Okay.
Yes, sir.
Which one you were able to see now?
Introduction. Introduction.
Now, objectives.
No, sir. It's stuck at introduction.
That is how to analyze the algorithms.
Yes, sir. How to
Okay.
analyze the algorithms, field of study.
Oh, okay. So let me give you an introduction, a brief introduction about this course, design and analysis of algorithms. There are two main words in this: designing an algorithm and doing the analysis on these algorithms. Given a problem, you have developed a system, you have developed or designed an algorithm, and you know the system. And you know what kind of input needs to be given to this algorithm for execution. And at this instance, you don't know the output. So after giving different instances of input, your algorithm is executed and you are going to get certain output. Earlier output is unknown. You know the system, you know what kinds of input you are going to give. Then when you get the output, right, you are going to check the quality of the output. And all of you know, when this algorithm is executed, it uses CPU to perform operations and it uses memory to hold the program and the data. It may use primary and auxiliary memory for the same. So when you execute, it uses CPU for performing operations and memory to hold the program and data. So when you execute the program, after getting the output, the one thing you will be interested to see is what kind of output, what is the quality of output you have got. Along with that, you also will be interested to see how much computing time is required and storage the algorithm requires. Right? So you are going to check what are the outputs I am going to get and how does the system perform and what is the quality in the output which we have got. We will also measure the complexity of the system to produce this output, that is in terms of time and space. We will check how much time does the system take to produce the output and what are the physical requirements of the system to produce the output. Are you able to see the next slide? Hello?
No, sir. Can't see the next slide. It's still at introduction.
Could you see it now?
Yes, sir.
Analysis of algorithm.
Yes, sir.
Yeah. So we'll be looking at what are the outputs, how does the system perform, what is the quality in the output, and also we will check the complexity of the system to produce the output. That is in terms of time and space. How much time does the system take to produce the output? And what are the physical requirements of the system to produce the output? This is what is analysis means. You know the algorithm, that means to say you know the system to solve the problem, you know what kind of inputs can be given, and by giving an input, different instances of input, you are going to get the output. So you'll be interested to check what is the quality of the output, so that you will be able to check the correctness of the algorithm. And also you will be very interested to see how does the system perform. The algorithm which you have written to solve the problem is performing. Performance in terms of space and time, right? The physical requirements of the system to produce the output and how much time does it take to produce this output. So that's the main goal of your analysis. These are all the analysis of the algorithm which you have developed. You are going to see what kind of output you are getting and in terms of time and space. So then there is a design problem, right? So you need to design a system. Given a problem, you know what is the input and what is the expected output, you will know. And that becomes a design problem. So designing an algorithm or designing anything is an art. You may design a car, you may design an aeroplane. So it's an art, but there are certain standard techniques algorithms use to solve this problem in the field of computer science, and you are going to look at those algorithms while designing. So in terms of design, you know the problem statement, you know what is the input needs to be given, and you know the expected output, but you don't know the system. So what should be that system that produces the desired output from the given input is a question. So this is realizing the system. This is a synthesis problem, or you need to design an algorithm. Are you able to see the next slide? Hello?
Yes, sir. You can see.
Okay. That means to say at the outset it is algorithm is a method to solve the problem, right? So input is a problem, output is a solution which you are looking at, and the system is a problem solver that is given by algorithm. So algorithm basically, if you see, it's a method to solve the given problem. When you solve the problem, you are going to get the solution. So to convert from problem to solution, you require something in between, which is a system. We need a problem solver, somebody who could solve the given problem. So that's an algorithm for us. More technically, if you see, an algorithm is a precise method that should be implemented on the machine in order to find a solution to a problem. It is just not just a method, it's a just precise method that should be implemented on the machine in order to find solution to the problem. So the problem is given, you will find the solution. There should be someone who is transforming this problem into the solution. The one who saw, do this transformation is an algorithm for us. Are you able to see the mapping function slide?
Yes, sir.
Okay. So there is somebody who is doing the transformation. So algorithm could be thought of a transfer or a mapping function in which a set of input is given to your algorithm and you may get one or more output. The one who converts the input instances into output is your algorithm, which we can consider it as a transfer or mapping function. So then what is an algorithm is? An algorithm is a sequence of unambiguous instructions for solving a problem, that is, for obtaining a required output for a legitimate input in a finite amount of time. So the reference to instruction in the definition here implies that there is something or someone capable of understanding and following the instructions given. So the one who does that, we call it as a computer. So there are instructions given to solve the problem. There is somebody to understand the problem, these instructions, and given an input, following this instruction, we are able to convert it into output. So earlier, these instructions would have taken by a human being who used to take this instruction and perform the calculation, given an input and produce the output. Now, as you know, these computers, which are the ubiquitous electronic devices, it has become indispensable in almost everything we do. So these instructions are taken by the computer. So this algorithm tells you the step-by-step method to solve the problem. So that's an algorithm for you. So an algorithm is a sequence of unambiguous instructions. It should not be an ambiguous. Add 2 or 3 is an ambiguous statement. Either you should say add 2 or you should say add 3. Not 2 or 3. 2 or 3 becomes an ambiguous statement, and if your computer sees that an ambiguous statement, right, ambiguous statement, then it will not be able to go further, take next instruction. So this sequence should be sequence of instructions which you give should be of unambiguous in nature. And when you give this instruction, that instruction should take a finite amount of time. It should not take years together to complete those problems, which you will not be interested in. So these algorithm which you have written, which is a set of instruction to solve particular problem, has to be completed in finite amount of time. So notion of algorithm and a problem, input, or we can say instance of an input, which is fed into the computer to get the output. One such examples of computational problem is sorting problem. Statement of the problem, you will have an input, a sequence of n numbers, a1 to an. So the output is a sequence a1 to a1, so that a of 1 is lesser than a2, a2 is lesser than a3. So that a of I is lesser than equal to aj. That is a given sequence of numbers, which is not given sequence of unordered numbers. Your output is to get an ordered set of elements from a1 to a1 such that ai is lesser than equal to aj. That is the expected output given an input. The statement of problem here is given, then one of the instances is shown wherein a sequence of input is given 5, 3, 2, 8, 3. You should get output as 2, 3, 3, 5, 8. So now you need to come up with an algorithm to sort the given input and get the sorted output. So that's the problem to solve, and you need to come up with algorithm to sort these elements in an ascending order or descending order. So if it is given that you need to sort this in an ascending order, then you need to write an algorithm. A sequence of instructions needs to be given to solve this problem. Now there may be different kind of sorting techniques, different kind of algorithms which could be used to convert a given sequence of unordered elements into an ordered set. So the famous algorithms which are available are selection sort, insertion sort, merge sort, and many such algorithms are available. So these comes under different algorithm solving techniques, different design strategies like selection sort, insertion sort, merge sort comes under different design strategies, and you are going to learn these design strategies when you are learning these sorting algorithms. This is one such example of a computational problem. There are many such problems in computer science you are going to solve, and you are going to look into such problems in the due course of time. That is, when you complete this course, you will be understanding different design strategies which you could use given a new problem in your real world scenario in your future. If given a new problem, you will be able to comprehend the techniques which you have learned and apply these techniques, design strategies there, and you will be capable of coming out a good algorithm for an unseen problem which is given to you in future. So this is one such example, and the some well-known computational problems which you are going to solve in this course are sorting, searching, shortest path in the graph. For example, if you wanted to send a packet from source to destination, okay, so you are making it as a graph. The whole network is represented as a graph, and given a source and destination, you will be able to write an algorithm which finds the shortest path from source to destination. If you wanted to travel, and if you are given a Google map, and where every junction you are going to represent it as a node, and roads connecting to these areas as a edge in a graph, you will model the air network or the road network as a graph. Then given a source city and a destination city, you will be able to come up with a shortest path possible to travel. So such shortest path algorithm we are going to discuss. So then you are going to also work on something of minimum spanning tree. Given a network, if you wanted to broadcast a message, then you are going to come up with a spanning tree. The graph you will convert, given a graph of the network, you'll be able to convert it into a minimum spanning tree. From the node, if you broadcast a message, it could reach all the destination in a minimum time. So by generating a minimum spanning tree, you are trying to optimize the time taken to broadcast the message. So you are going to solve such graph algorithms. You are going to see some more algorithms like traveling salesman problem. Given different set of cities, traveling salesman's problem states that he has to travel a minimum distance and visit all the cities. So how you are going to come up with an efficient algorithm for this? You are going to see this traveling salesman problem in under different design techniques. Then you are also going to see some problems like knapsack problem, Jawasafani problem, playing chess. So these are all the kind of problems you are going to see, right? So the basic issues related to algorithms are how you are going to design an algorithm, how to express this algorithm, and once algorithm is developed, you are also seeing how to prove the correctness of this algorithm. You will also do the complexity analysis of the algorithm. The two kinds of complexities you are going to see, one is theoretical analysis and empirical analysis. In theoretical analysis, you are just going to write an algorithm. You are not going to write it in certain programming language. Your analysis does not depend upon the compiler which you are going to use, the programming language which you are going to use. You wanted to do the analysis of the algorithm written independent of the programming language used, independent of the machine being this program is executed, independent of the compiler which you are going to use for compiling this program. So you are going to learn how you are going to do this without using all these things. Given a problem, you will develop an algorithm, you will express this algorithm, and then you will prove the correctness of the algorithm using pen and paper, right? You are going to give an input, instance of an input to the algorithm. You are checking whether expected output, whether it's generating the expected output or not. So if it generated an expected output, all possible cases you have to give to your algorithm to prove the correctness. So once you prove the correctness, you will see how much time it's going to take without running on any of the machine, without using any programming language, converting this algorithm instructions into a code in a particular language, without using the compiler to compile and execute this, compile this code. So without using that, you are going to see how we are going to do the analysis of the algorithm which is developed in terms of time and in terms of space. Then also you will take the system time into the consideration, and giving numeric data, you are going to see do the empirical analysis. And when you write an algorithm, you need to write a optimal algorithm. And then you have to write an algorithm which is optimal in terms of space and time. So the optimality is very important thing while developing an algorithm. You are going to understand how to develop an optimal algorithm by using a different design strategies on the problems, on the different problems which was specified. You will be looking in each unit, you are looking at different kind of techniques in this course. Right, what kind of such things you are going to see? Right, so let us look into a detailed course content. Before detailed course content, I'll also show you what are all the techniques we are going to learn in each. Right, can you see the design and analysis of algorithm syllabus?
Yes, sir.
Yes, sir.
Okay. So our unit 1 comprises of 12 hours of teaching, where we will introduce you what is design and analysis of algorithms is, what is design is, what is analysis is. Then after introductory class, I'll be talking about analysis of algorithm efficiency. We are going to see the framework to find the algorithm efficiency, and we will see some algebraic structures. Then we are going to talk about some techniques like a brute force technique in unit 2. Right? After discussing the analysis framework in unit 1, a framework tells you how you are going to do the analysis using some of the discrete mathematical structured concepts like you will use summation formula, and you will use backward substitution methods to do the analysis of an algorithm. You will do the analysis of both recursive and non-recursive algorithm, and you will be able to tell theoretically, without even running the program on the computer, you will be able to tell us what is the efficiency of that algorithm is. We are going to see in detail how to find those efficiencies using summation formula and backward substitution methods on both the recursive and non-recursive algorithm. We will develop a framework for both recursive and non-recursive algorithm in the unit 1. Once we have done that, once we have a framework to do the analysis, from second unit onwards, we are devoting it to a particular design strategy. When you are developing an algorithm, you are going to see, for example, for sorting, you are going to use brute force method, or you may use divide and conquer method. So brute force method to sort could be your bubble sort. In divide and conquer, it could be a merge sort. For an example, if you take a sorting problem. So we are going to take such problem in each unit, and we are also understanding what kind of algorithmic strategy is used, or what kind of techniques are used. Unit 2, one such technique which we start with is brute force. Brute force method is a straightforward approach to solve the problem. It directly based on the problem statement and the definition of the concepts involved to solve those problems. So it's a straightforward method which you'll use, which is called brute force method. In divide and conquer method, you will divide the problem into smaller instances of the same problem, ideally about same size. Then you will solve the smaller instances. Once you solve the smaller instances of the problem, the final solution is obtained. For the smaller instances are merged together to get the final outcome. So that's how you do, you use technique to sort. For example, I said a brute force method is to use a bubble sorting techniques. In divide and conquer, you will use merge sort. Given, how does merge sort work? Given two arrays of sorted array. If I give you two sorted array, you will merge these two. Once you merge, all the elements should be in sorted order. So first you will take the problem, you divide it into a smaller subproblem, and once you sort this smaller subproblems, you will merge it to get the solution for the original problem. So this is one more technique which you are going to discuss in analysis and algorithm apart from brute force, which is divide and conquer. These are the two techniques which I'll be covering it in unit 2. In unit 3, we will see a technique called decrease and conquer. In decrease and conquer, the problem could be decreased by a constant factor, and you can do a variable size decrease as well. So you decrease the problem using three different variants, then you find the solution for the same. So transfer and conquer, you will transform the instance of a problem and you will find the solution. Some of this transfer and conquer technique, you have done it in your data structure, like AVL trees or your heap sort comes under this transfer and conquer. The extension of AVL tree, some of the techniques which we are going to do is in unit 3. So we will also understand in detail why these problems which you have solved are called transform and conquer technique. This we are going to discuss it in the unit 3. In unit 4, you are going to discuss about space and time trade-offs. For example, given an input instance, you will use an additional space to create a table. For example, if you are searching for a pattern in a string, you can do it in a brute force method, or you can create a table which requires an additional space to improve the performance of search. If you wanted to make search faster, in case of brute force method, you need to shift your pattern one by one, and you compare the pattern with the string in the text, and if it is matching, you say pattern is matched. If there is a mismatch in any of the word, any of the character, you will say pattern is not matched. So given an m size array and n size pattern, you should move this pattern one by one in the text and do it. That's a brute force method. Now you have a table wherein you will store certain information which aids in improving the performance. So many such algorithms. One such algorithm is string matching, which I'm discussing here. But many algorithms, you will allocate an additional space in to improve the performance or the time, to improve the time the algorithm takes. So you will learn something called space and time trade-offs. You give an extra space to reduce the time. So such algorithms are discussed, and there is one more technique in unit 4 which we are going to discuss is greedy technique. You will try to solve the problem in a greedy way, and I'll explain you what is greedy technique all about in unit 4, and we will be talking about limitation of this algorithmic power in the unit 5. Okay, these are all the techniques which we are going to learn in our design and analysis of algorithm course. There are a lot many techniques which you are going to learn: brute force, divide and conquer, decrease and conquer, transform and conquer. You will also understand how you can use extra space in order to improve the efficiency of an algorithm in terms of time. You will do a trade-off between the space and time. Then the final technique which you are going to learn is greedy technique. Once you see the limitation of algorithmic power, you will also learn a technique called backtracking. Okay, so the detailed syllabus or course contents, I'll show it tomorrow, right? With the introduction, unit 1, unit 4 is brute force and divide and conquer. Unit 3 is decrease and conquer, transform and conquer. Unit 4, space and time trade-offs and greedy technique. The last one is limitation and coping with limitations of algorithm power. You will also see a dynamic programming and a backtracking technique, right? And this knapsack problem is discussed, as you can see, in the unit 5. Also, you are going to discuss that, in using some other technique as well. So in the next class, we will see in detail what are all the contents of this course, and we will move on from there to come up with a framework for algorithm efficiency. Thank you.